Hello grade 12, Mr. G here. We are going to be doing now a video on physical properties and homology series. In the previous one, in last video for grade 12, we did one about homology series and intermolecular force. Now the next one will be physical properties and homologous series. Okay, so in this video, first of all, let's find out about the different physical property we have to learn here in grade 12. There's only three, so there's not too many physical properties. The first one is about boiling point. Now, what is boiling point? Boiling point is the temperature at which the vapor pressure of a substance equals the atmospheric pressure. Temperature where vapor pressure is equals to atmospheric pressure. That is the definition that you have to mention if the question asks you to define boiling point. Is the temperature at which the vapor pressure of a substance equals the atmospheric pressure. Second property, melting point. Melting point is the temperature at which the solid and liquid phases of a substance are at equilibrium. Liquid, solid, and liquid phases are at equilibrium. So that definitions you have to learn it. The last physical property you must learn is vapor pressure. Vapor pressure is the pressure exerted by a vapor at equilibrium with its liquid in a closed system. So U also is the pressure exerted by vapor at equilibrium with its liquid in a closed system. We have to learn these definitions because they are going to ask. Okay, now what is the next very important? I guess it might be the most important part in this specific video. You have to learn that the stronger the intermolecular forces, the higher the boiling and melting point, the lower the vapor pressure. All this one is very important. The stronger the intermolecular force, the higher the boiling and melting point, and therefore the lower the vapor pressure. Note, boiling and melting point is the opposite of vapor pressure. If the boiling and melting point is high, then the vapor pressure is low. If the boiling and melting point is low, then the vapor pressure is high. So this is the first important thing we have to learn, and I guess this here is the most important part in this video. You have to learn that one. The stronger the intermolecular force, the higher the boiling point. Okay, so substance that, for instance, have a hydrogen bond will have higher boiling point than the substance that has dipole, because hydrogen bond is a stronger intermolecular force than dipole. We will see examples just now. Okay, now this one is also very important for compounds with similar molecular mass as surface area. This is like a subtitle. Sorry, that one. This is like a subtitle that we are going to be looking. If the compounds which have similar molecular mass and surface area, the higher the boiling point and the melting point, the lower the vapor pressure. We're going to start with this specific homology series. So if the compounds, all these compounds, it does not matter, the homology series must have similar molecular mass and surface area. So on this left hand side here, we are going to see higher boiling point, and as you move to the right, we'll have lower boiling point. So we go here to a carboxylic acid is the first one. Now carboxylic acid have the highest boiling point and the lower vapor pressure. Remember, compounds that have similar molecular mass and surface area. So why carboxylic acid? Let's remember, what does it have? It has hydrogen bonds. And remember, hydrogen bond is the strongest one, but it has two sides. Two sides for hydrogen bond. So from all the homology series we did, hydrogen bond is in carboxylic acid. We have two sides, and therefore carboxylic acid has the strongest intermolecular force and will have the higher melting and boiling point and the lower vapor pressure. Second is alcohol. Now alcohol also have hydrogen bonds, but only one side. So the strongest one is carboxylic acid, followed by alcohols. Alright, remember, carboxylic acid is stronger because it has two sides for hydrogen bond, while alcohols have only one. Then is coming this group here, aldehydes, ketones, esters, and haloalkane. All of them has dipole. All right, and then finally is coming the hydrocarbons, which they have London forces. This is just recalling from last video, but the important part is here. The boiling point of carboxylic acid are higher than the boiling point of alcohol, and the boiling point of alcohol is higher than... Okay, I'm back. I apologize, my cell phone was ringing and I actually forgot to put it inside. So we are here in terms of boiling point. So alcohol have higher boiling point than aldehyde, ketone, esters, and haloalkane, and all those will have a higher boiling point than alkanes, alkene, and alkyne. Okay, so this is not very difficult, it's just to remember. Now let's see the steps to explain the difference in the boiling point or melting point of vapor pressure for different compounds. Okay, so there are 4 steps. Okay, step 1, always you are going to identify the homologous series and the type of intermolecular forces for that specific homologous series. Second step, you are going to compare the strength of the intermolecular forces. So here you have to say hydrogen bond is stronger than dipole. Or if you already mentioned, you have to say the intermolecular force in compound A, for example, is stronger than the intermolecular forces in compound C, and so on. Step 3, you have to speak about the energy needed to break the intermolecular force. So the stronger the intermolecular force, the more energy needed to break the intermolecular force. And important, we have to speak about intermolecular force. We cannot mention the word bonds, and learners attempt to make a mistake and say the stronger the intermolecular force, the more energy needed to break the bonds. Since the moment you say to break the bonds, then you lose the marks. Okay, or the other way around, you say the weaker the intermolecular force, the less energy is needed to break it. And finally is the conclusion about boiling point, melting point, and vapor pressure. It depends what the question is asking you about. So moving back, step 1, identify the homology series and the type of intermolecular force. Step 2, compare the strength of the intermolecular force. Step 3, speak about the amount of energy needed to break that intermolecular force. And step 4, go to the conclusion related of what is the question asking you about. Okay, so let's see one example how this question could be asked. Let me just zoom a little bit for all of you. I'm sorry about that. Question 3, this is a question 3 from Northwest, September 2015. Okay, it's a good question. We're going to look at that one. Let's say the table shows the data collected for 3 organic compounds, A, B, and C, with different functional groups during a practical investigation. Here's a table. You have compound A, B, and C, and you have here melting point on the right hand side. Okay, so the question said 3.1, name the following in this investigation. This is important. It's a general question. It's always going to be a question about investigation in the exams. First of all, the independent variable. 3.1.2, the dependent variable, and 3.1.3, the control variable. Now let's answer that one before we go on reading. Okay, so let's go and answer that 3.1.1. So we are in 3.1. Okay, now they're asking you to identify the independent variable. Remember, independent variable is the variable that we are changing. What are we changing? We're changing these compounds here. We're changing the compounds there. Okay, now what are we changing of the compound? We're changing the functional group. We're changing the homology series. So when you go to the independent variable, you can write the functional group, or you can write homology series, because that is what you change. Or you can write functional group, or you can write even organic compound. and there is 1 mark for that. 3.1.2, they say the control variable. Now the control variable, the dependent variable is the variable that depends on the independent. So what is going to change if you change the compound? The melting point. So this one here is going to be the dependent variable. It's going to be the melting point. Melting point, and you will get 1 mark for that. And 3.1.3, they're asking you about the control variable. Which one is the one that we must keep constant? If we go to this part of the video, they said step to explain before that one, we need to know that the compounds must have similar molecular mass. So molecular mass must be the control variable here, or surface area. They must have similar molecular mass. Remember, the control variable is that one that we keep constant. Okay, so it's going to be the molecular mass, and that is 1 mark for molecular mass. Now question 3.2, we almost in the part that is important for this video. The question 3.2, write down the homology series to which compound C belong. Now remember, we need that one anyway. So compound C, you can see here the functional group. On this side here is the functional group COOH, and that one will be a carboxylic acid. So that will be a carboxylic acid. Carboxylic acid, and there is 1 mark for that. Okay, let's go to question 3.3. Write down the general formula for compound A. So we have to identify compound A. You can see it is an alkane. It is an alkane, and then you have to write down the formula for alkane, the general formula for alkane. 3.3, general formula for alkane is CnH2n plus 2. All right, you can go there. You have 2 carbon, and then hydrogen you'll have 6. So if carbon you have 2, for hydrogen you have 2 times 2 is 4 plus 2 is 6. Okay, so we have there the total number of carbon, and this one is how many marks? It is 3.3, 2 mark for writing the general formula, 1 and 2 marks there. We're going to question 3.4. 3.4. Now describe the trend in the melting point from A to C as shown in the table that we are speaking about. What can you see here? The melting point is increasing as you move from A to B to C. So that is all you have to write. The melting point is increasing as you go from A to B to C. Okay, now that is the first part. They're asking you what is the trend. The trend is what is happening to the melting point. You can see it's moving from minus or negative 183,3 to 114 negative, so increases, and then as it moves to C, increases even more. Okay, so that is the first part. And the last part say describe the trend, explain the trend in question 3.4. So that one was 2 marks for that one, 2 marks for saying that. And then 3.5, we are going to explain this trend. All right, to do this part, we're going to follow the steps we said. Okay, step 1 is to identify the homology series and the type of intermolecular forces. So compound A, let's do it here. What is that? It's an alkane. It's an alkane. What type of intermolecular forces have? London forces. London forces. Let's go to compound B. What is compound B? Is an alcohol. What is intermolecular forces have? Hydrogen bond. How many sides? One side. And what is compound C? It's a carboxylic acid with hydrogen bond. But two sides. That is step one. We identify the homology series. You can see here we have the homology series for each of them, and then we identify the type of intermolecular forces that each of them has. So that is step one. Obvious, this one must be written in a paragraph. Compound A is an alkane with London forces. Compound B is an alcohol with hydrogen bonds, or with one side for hydrogen bond. And compound C is a carboxylic acid which have two sides for hydrogen bond. Let's go to step 2. Now, in step 2, we have to compare the strengths of the intermolecular forces. So, we can say, for example, two sides of hydrogen bond is a stronger intermolecular forces than one side of hydrogen bond. And one side of hydrogen bond is a stronger intermolecular forces than London forces. Or you can just say the intermolecular forces in compound C are stronger than the intermolecular forces in compound B and the intermolecular forces of compound B are stronger than the intermolecular forces. Let's write with the symbol, in compound A. The intermolecular forces in compound C are stronger than the intermolecular forces in compound B, and the intermolecular forces of compound B are stronger than the intermolecular forces in compound A. I don't have to mention the name because I already did it in step 1. However, if you want, you can use the name of each of the intermolecular forces. Okay, let's go to step 3. Now, in step 3, we have to speak about the amount of energy needed to break the intermolecular force. So, you have to say here that more energy is needed to break the intermolecular forces in compound C than B, and B and more energy to break the intermolecular forces in B than C. So that is step 3. More energy is needed to break the intermolecular forces in compound C than B, and more energy to break the intermolecular forces in B than C. Okay, so I hope, than A. That is a mistake here. We're moving up than A. Sorry about that one. Please forgive me. Okay, so than A. So we know now that part. And then the last step, now we're going to the conclusion about the boiling point. So therefore the boiling point, the melting point, remember we're speaking about melting point. The melting, let's just fix that word. The melting point in compound C is higher than B and B higher than A. This is the question. Now let's go back here very quick. First of all, to identify the homology series, all this one can be done in a paragraph. Alright, so you have to write everything in a paragraph. Alkane, compound A is an alkane with London forces, compound B is an alcohol which has one side for hydrogen bond, and compound C is a carboxylic acid which have two sides for hydrogen bond. The intermolecular forces in compound C are stronger than the intermolecular forces in compound B, and the intermolecular forces in compound B are stronger than the intermolecular forces in compound A. Or you can go and say two sides for hydrogen bond is stronger than one side for hydrogen bond, and hydrogen bond is stronger than London forces. Is more or less the same. Step 3, you are going to speak about energy. The one that have the strong intermolecular force will need more energy. So more energy is needed to break the intermolecular force in compound C than B, and more energy to break the intermolecular force in B than A. And finally, the conclusion, we have to speak about the question. In this case, it's melting point. The melting point in compound C is higher than B, and B higher than A. I hope this is understood. This is explaining the trends. You can always go the other way around and moving from B to A instead. Okay, so thank you very much. I hope it helped. Next video is going to be about still physical properties, but we are going to be speaking now about length of the chain and surface area. Okay, so I hope this is understood. Thank you very much. Good luck. Up to the next video.